Imagine a planet so grand, so magnificent, its rings would dwarf even those of our beloved Saturn. For years, the internet, and even some scientific headlines, buzzed with the idea of J1407b, the Super Saturn, a gas giant, thought to be hundreds of times larger than Saturn, adorned with a colossal ring system spanning millions of kilometers. It captured our imaginations, painting a picture of an alien world unlike anything we'd ever seen. To put it into perspective, Saturn's majestic rings, while vast, would easily fit within the distance between Earth and the Moon. But J1407b's hypothetical rings, they were theorized to be so enormous, so impossibly wide, that if placed in our own solar system, they would extend beyond the orbit of Mars. A truly mind-boggling scale that would redefine our understanding of planetary formation. It was a discovery that promised to rewrite the textbooks. The story of J1407b began in 2012. Astronomers from the University of Rochester, using the Super WASP project, observed a peculiar dimming of light from a star designated 1, SWAS, PJ 140747.93-39145.4. This wasn't just a simple dip. It was a complex series of eclipses, lasting for weeks, with multiple distinct decreases in brightness. The pattern was incredibly intricate, suggesting something massive was passing in front of the star, something with an incredibly complex structure. The leading hypothesis, and the one that captivated the public, was that a giant exoplanet, truly a super Saturn, was responsible. The intricate light curve seemed to perfectly fit a model of a planet with an extensive multi-ringed system, where gaps in the rings allowed more starlight to pass through. It was a compelling explanation, and for a while, it seemed like we had found our cosmic giant. The sheer size of the inferred rings was what made the Super Saturn moniker stick. But science is a process of constant refinement, of questioning assumptions, and of seeking out the most accurate explanations. Even as the Super Saturn narrative took hold, some astronomers began to voice their doubts. The sheer mass required for such a planet to maintain such a massive, stable ring system was a challenge. And the long duration of the eclipses, while consistent with enormous rings, also hinted at something else. The prevailing theory, the Super Saturn idea, while exciting, began to unravel under closer scrutiny. The biggest crack in the armor, the host star itself. J1407, the star around which this mysterious object orbited, is a very young star, only about 16 million years old. This is crucial because young stars are often surrounded by what's called a protoplanetary disk. A protoplanetary disk is essentially a cosmic construction zone. It's a vast, rotating disk of gas and dust from which planets are born. Think of it as the raw material for solar systems. These disks can extend for vast distances and contain significant amounts of material. And importantly, they are often lumpy, with areas of varying density and gaps where planets might be starting to form. This is where the alternative explanation comes in. Instead of a colossal, ringed planet, what if the eclipsing object wasn't a planet at all, but rather the star's own protoplanetary disk passing in front of it? A young star with a surrounding disk, viewed edge-on, could easily produce the complex and extended dimming patterns observed. The gaps and denser regions within the disk would naturally account for the intricate variations in the starlight. While a ring system is primarily composed of ice and rock particles orbiting a central planet, a protoplanetary disk is a dynamic, evolving cloud of gas and dust. The features that create the dips in the light curve would be inherent to the disk structure, rather than a stable, massive set of rings. This explanation not only fits the observed light curve, but also aligns much better with what we know about young stellar systems. So, the current scientific consensus is this: J1407b, the super Saturn, as we imagined it, doesn't exist. The B designation, which usually indicates an exoplanet, is now understood to represent the phenomenon of the eclipsing material around the star J1407 itself. It's not a planet with rings. It's a young star still in the process of forming its planetary system, shrouded by its own expansive and intricate protoplanetary disk. This doesn't make J1407 any less fascinating, however. In fact, it opens up a new window into the very early stages of solar system formation. Observing these complex disk structures provides invaluable insights into how planets are born. From swirling clouds of gas and dust, we're seeing a star in its infancy, perhaps even witnessing the birth pangs of future planets within that very disk. While the idea of a super Saturn was undeniably captivating, the reality is arguably more profound. It's a testament to the dynamic and often surprising